Now, let's talk about number 4. Owen and Paul play a game of Pascalino using the graph nodes below. Owen and Paul fill in the nodes of the top row from left to right, alternating with Owen first, then Paul choosing a different integer between 1 and 6 inclusive to fill each node. Once all the numbers are chosen, each node below the first row is marked by the sum of the two nodes directly above it. Owen wants to minimize the number in the bottom node, while Paul wants to maximize this number. When both players play optimally, what number will be in the bottom node? Well, first of all, if we label these A, B, C, D, E, and F, then we can start labeling all of these points below. So this is going to be A plus B, B plus C, C plus D, D plus E, E plus F. I'm not going to add through the entire triangle. However, if you do follow that process, adding together each of the two nodes above a particular point to find that particular point's value, all the way down to this bottom node, you're going to find that this bottom node is going to, no matter what, have a value of A plus 5B plus 10C plus 10D plus 5E plus F. And we know that Owen goes first, so Owen fills A, then Paul, Owen, Paul, Owen, Paul. Now, since multiplying by 5 is only ever going to not be optimal if you're jumping from 1 to 5, trying to pick where to put 1, and multiplying by 10 is always going to improve the value of the placement of a number. Owen is, since he tries to minimize the number, he should notice that Paul, if Paul is left alone, would be able to put 5 times 6 in place B, if he was able to put 6 in place B. So Owen is going to make A 6. That's his optimal move, because no matter what small value he puts in here, if he were to do so, Paul would be able to handily beat his minimization advantage by putting 6 in place B. So Owen is going to put a 6 in A. Now let's think about what Paul is going to put in B. Notice that no matter what Paul does in B, Owen is not going to want to put 5 in place C. So Paul shouldn't put 5 in place B, because there's nothing that's going to stop him from putting it in place D. And 50 is going to be better for his ultimate maximization than 25. So Paul's not going to put 5 in place B. And from then, it's a question, does he want to put 1 in place B to keep Owen from using 1 in this 6 times place? Or does he want to put 4 in B to get that score of 20? So let's go ahead and branch off. B could either be equal to 1, or B could be equal to 4. Now, if Paul chooses 1, then Owen has to put at least 2 in place C. And once Owen puts 2 in place C, Paul puts 5 in place D. Then the only things left to assign are 6 and 4. Owen, since he wants to minimize, will put 4, and Paul will put Owen will put 2, Paul will put 4. And that's going to get us a score of 6 plus 5 times 1, or 5, plus 10 times 2, or 20, plus 10 times 5, or 50, plus 5 times 3, or 15, plus 4. 20 plus 50 is 70, 5 plus 15 is 20, that's 90, 6 plus 4 is 10, so that's 100. In the case of B equals 1. If B equals 4, then again, the first number will be 6, and then 5 times 4 is 20. And then from there, Owen wants to minimize C, so Owen's going to choose 1, getting us 10. And then Paul will choose 5 to get 50. Owen will minimize E to get 10. And Paul will be forced to use 3. Then if this is the case, then we have 10 plus 50, which is 60, plus 20 is 80, plus 10 is 90, plus 6 plus 3 is 99. So the two possible scores are 100 and 99. And it's entirely dependent on Paul's choice for what goes in B. Paul wants to maximize the number, so he's going to choose to put 1 in the B spot, giving him a score of 100.
This is Tim. Hope you're enjoying our videos. If so, you know what to do. Like, subscribe, turn on notifications, all that sort of thing. But what I'd really want to invite you to do is to send us an email at media@mathleague.org. Tell us which problems you'd like to see us cover next in our video series. Take care and see you in the next video.